Hi, and welcome to 3.05 Ionic Bonding and Writing Formulas. These are the Common Core standards we are addressing. The lesson objectives is to determine the ionic charge based on location of the periodic table and to demonstrate an understanding of ionic bonding by writing chemical formulas. The first vocabulary term we see is ion. An ion is merely an atom or a group of atoms that form a charge by gaining or losing one or more electrons. Recall from Module 2 that you learned about number of protons, number of neutrons, and number of electrons. When we change the number of electrons, that is called an ion. There are two types of ions that can be formed. We have cations, kind of think of a kitty cat, which is an ion that has a positive charge. Cations are going to lose electrons to form a positive charge. The other type of ion that we see is what we call an anion. Anion is an ion that has a negative charge. Anions gain electrons. Cations are typically your metals as well as hydrogen. Even though hydrogen is a nonmetal, it likes to form a cation. Your anions tend to be your nonmetals. Cation will lose electrons to form that positive charge. Anion will gain electrons because remember, electrons are negatively charged. So if I gain electrons, I'm going to have a more negative charge. With cations and anions, we can classify them based upon how many there are. We have monoatomic ion, which is what we're going to see in lesson 3.05. Mono, of course, means one, so monoatomic means an ion consisting of one element. And just to give you a quick preview of what's coming up, because lesson 305 and lesson 308 do go hand in hand, and it would actually be okay if you jumped to 308 next and then come back and do 306 and 306B and 307. So in 308 you're going to get back to ionic naming and bonding, and you're going to learn all about polyatomic ions. Polyatomic ions are where we have two or more atoms bonded together. Kind of think of it like a family unit. We have two or more atoms that come together, and as a group they form a charge. With monoatomic or polyatomic, they could be positive or negative. Quick review. Cation, an ion that has lost electrons and becomes a positively charged particle. Anion, kind of like the antagonist, it's the negatively charged particle. Anions will gain electrons. Now, what determines how many electrons each atom will lose? As you guys have noticed, I've been saying one or more. How do we know if an atom is going to lose one electron, or two electrons, or three electrons? Remember from lesson 2.06, we learned about the valence electrons. We have to remember those valence electrons in order to determine how many electrons an atom will lose. So I have this picture here from lesson 2.06. If you want to go there, I definitely recommend keeping this picture in your folder. The valence electrons tells us how many valence electrons we have. This little table. So here we see hydrogen has one valence electron. Oxygen has 6 valence electrons. Well, oftentimes atoms are going to bond in order to lose or gain electrons to either fill or empty their valence shell, whatever is easier. And when I say easier, that means less energy. Atoms are kind of lazy too. They don't like to use a whole lot of energy. So whatever they can do to use the least amount of energy, that's what they're going to do. And that's what I refer to as being easy. Let's look at oxygen. Oxygen has 6 electrons in its valence shell. So it can either lose 6 to empty the shell, or it can gain 2. Because remember, once you hit this section, we get into the p orbitals. Therefore, we have a total of 8 electrons in that shell. So is it easier to lose 6 or to gain 2? Probably just to gain 2. Therefore, oxygen will form a 2- charge. Now you might be looking at this screen right now, listening to this recording going, oh my gosh, I don't remember all those orbitals and I don't remember valence electrons too much. And it's okay, just take a deep breath. You don't have to have mastered it, just kind of have an understanding of where the charges come from. The good news is in 3.05, there is a periodic table of common ionic charges for just your main group elements. This only works for your main group elements, which is your first 2 columns of the periodic table, as well as the last 6 columns of the periodic table. I definitely recommend that you print this and put this in your chemistry notebook because you need it for much of the rest of Module 3, and you need to be able to do this for all of Module 4 and a lot of second semester. So set yourself up for success by saving and putting this in your chemistry notebook so you can refer to it quickly. In this, what you do is if you have an element that is a main group element, first 2 columns or last 6 columns, you find the element. Let's say phosphorus, P. Okay, it's over here on the right hand side, and then all you do is you go to the top of the column and you see a -3. What that means is all elements in that column are going to form a -3 common charge. Now why does it form a -3 charge? That's where we go back to the valence electrons. Phosphorus has 5 valence electrons. Therefore, it is easier for it to gain 3 electrons. Remember, a negative charge indicates gaining electrons. So it's going to gain 3 electrons to fill that valence shell, and then phosphorus is very happy. You might be asking yourself, well, what about this column? This column's kind of weird. It's got +2 or +4. Honestly, you're not going to see too much with this column, especially these top 3 elements. They don't like to do a whole lot for ionic bonding. The bottom 2 elements like to do ionic bonding. These are what we're going to call special metals. Therefore, they're going to be in 3.08. We're going to actually cover those there because they do some weird things. They can actually form multiple charges, and that complicates things a little bit. So tin and lead we're going to actually study later, as well as the middle part of the periodic table. Okay, so what I would like for you to do is to practice determining the ionic charge. So please pause this recording, write down these examples, and write down what the charge would be. Welcome back. The first one we see is calcium. We have to find calcium on the periodic table. Here it is over on the left-hand side. We go to the top and we see it forms a +2 charge. So when we write it out, it's going to be calcium 2+. Phosphorus, we just talked about, that's over here on the right-hand side. So it's going to be phosphorus with a 3-. And notice that the charge is a superscript. Hydrogen is right here at the top of the first column, so it's hydrogen 1+. Kind of looks weird, doesn't it? So really, we just write plus. If the charge is 1+ or 1-, we don't really ever write the 1. You'll never see it like that. Sulfur is over here on the right side of the periodic table. We look up at the top and it has a -2 charge. So we see that sulfur with a 2-. Aluminum is in the same period as phosphorus and sulfur. We look up at the top and we see aluminum, which is Al, and that has a 3+ charge. Iodine is way over here in group 7. It's a halogen, and all the halogens form a -1 charge. Once again, when you have the 1-, you don't have to actually write 1-. You can just write the negative sign. I kind of mentioned the special metals. The special metals we're not actually going to cover in this lesson. We're going to cover those in 308. So we really want to make sure that you guys understand 305 well, because there's a lot of information in 308. But for right now, some of you guys might be saying, well, we're not really doing much with the middle of the periodic table, and that's because those are special metals. They can take multiple charges. The special metals are the middle of the periodic table, tin and lead. Okay, so we have the middle, the transition elements. Those are our special metals. They have various charges. We'll do more with those later. Let's get started writing that formula. When we're writing ionic formulas, first thing we have to look at is that we always have a cation bonded to an anion. If you're losing an electron or 2, or 3, something has to be gained in it. So if we're losing electrons, something has to be gained in the electrons. And that electrostatic attraction is what forms the ionic bond. Please note that the cation, or the positive ion, is always written first in your formula. Elements will bond so that their overall charge of the formula is 0. How many ions you need of each element is going to be its subscript. Remember what an ionic bond is. It's a chemical bond that forms due to the transfer of electrons between a cation, which is a metal or hydrogen, and an anion. Anytime we refer to an ionic compound, it is a compound composed of the positive and negative ions, and they're combined in a ratio where the positive and negative charges cancel out. Therefore, the overall net charge is 0. Remember, the cation is always written first. A formula unit is something that you may hear us refer to. A formula unit is just the formula of the ionic compound. It represents the simplest whole number ratio of ions. I know it sounds like a lot, it's really not though, so hang in there. You're going to notice how easy this is going to be. Writing formula units. Basically, all that means is write the formula. Formula unit, formula, same thing. Don't let the words confuse you. So we are going to write the formula when calcium forms a bond with phosphorus. The first thing we do is we write each ion. We know calcium, phosphorus is P. Now we have to look up in that table that I told you to print and save in your chemistry notebook. We have to look up the common charge of each element. Calcium is a main group metal, therefore we can look at that and see that it has a 2+ charge. Phosphorus is on the right side of the periodic table. It is a nonmetal, and we look at the top of that column, we see phosphorus forms a 3- charge. When you do this, make sure that the positive is always to the left. Make sure it's written first. Now we have not written the formula yet. We're just starting. This is the first step. Next, we need to determine how many of each ion will it take to make the compound neutral. That will be their subscripts. When we look at their charges, we see that calcium has a +2, phosphorus has a -3. So if I only write 1 calcium, 1 phosphorus, that does not equal 0, does it? Not at all. In fact, I have too many negative charges. Therefore, I'm going to need another calcium ion. Because remember, calcium always has a 2+ charge. We cannot change that. Now I have a total of 4+, right? If I were to add up my charges, and I have a 3-, 4+, 3-, that does not equal 0, does it? Therefore, I have to have at least 1 more phosphorus because I have too many positives. So now I need another phosphorus. Well, now I have a total of 6-. 4+, 6-, still does not equal 0. I have too many negatives now, so I need to add another positive ion. So now I have a total of 6+, but look at that, I have a total of 6-, which when you add them together does equal 0. So it took 3 calciums and 2 phosphoruses, or phosphides is what we call them, to equal 0. Now how many ions you need is going to be their subscript. It took 3 calciums and 2 phosphorus ions to form a 0 charge. Therefore, my formula is Ca with a subscript of 3, P with a subscript of 2. And in 308, you're going to learn how to name this, and we call it calcium phosphide. So get used to that. Set yourself up for success in 308. The last step is always to check your work. Make sure that your overall charge is 0. If I have 3 calciums, which have a +2 charge, that's going to be a total of +6. If I have 2 phosphoruses, each of them with a -3, that's going to be a total of -6. +6, -6 definitely equals 0. I would love for you guys to do some practice on your own. Please pause this recording. You can rewind it if you need to go back through the calcium phosphide example again. Do it exactly the same way. Write down your ions. Figure out how many of each you need in order to have an overall 0 charge. You need that common ion chart and then you'll be able to write that final formula. Hit pause when you're ready to resume, hit play, and we'll go through them together. Welcome back. We're going to go through these. Number 1, aluminum and phosphorus. We see aluminum on the periodic table is in group 3A, therefore it forms a 3+ charge. Phosphorus, we've already seen, forms a 3- charge. When we look at this, we have a +3, -3. Well, that already equals 0, doesn't it? Therefore, I only need one of each element. Therefore, my formula is Al. Please make sure that the L is a lowercase. It is not a capital L. And then a capital P. Very important that you capitalize correctly for your elements. Number 2, calcium. Calcium is on the left side of the periodic table. It has a +2 charge. Lithium is on the left side of the periodic table. We have a plus charge. So what do? I hope you realize this, but we have a plus charge and a plus charge. They cannot form a bond. Two metals cannot form an ionic bond. Number 3, bromine, barium. Now you got to be very careful because remember, positive's always written first. So I recommend for you to go ahead and write it correctly. That way you don't make a mistake. Always have positive first. Barium has a 2+, bromine has a -1. That does not equal 0. I have too many positives, therefore I need to add another of my negative ion. When we add up our charges, we see that we have a 2+, we have a total of -1, -1, so that's a total of -2. 2 plus -2 equals 0. How many of each did I need? Well, I needed 1 barium and I needed 2 bromines. Therefore, my formula is BaBr with a subscript of 2. Barium bromide with an IDE ending. Again, you don't have to name these, but you will soon. Okay, so barium bromide. Number 4, nitrogen and fluorine. We look up on the periodic table, we see that nitrogen has a -3 charge, fluorine has a - charge. Uh-oh, did it again. If nitrogen is gaining 3 electrons and fluorine is gaining an electron, where's the electrons coming from? Therefore, they're not gonna form a bond. So if you got those correct, give yourself a big pat on the back. I'm going to teach you a quicker way to write the formulas. We must understand where the subscripts come from. And once you do, you can employ this new method and you're going to knock these problems out really quickly. It's called the crisscross and reduce. Potassium and nitrogen. Potassium is K and it has a plus charge. Nitrogen has a 3- charge. Crisscross and reduce means that you write the ions just like I did here. Okay, look up on that periodic table of common charges. And then what we're going to do is we're going to write the formula just leaving a little bit of space so we can write down the subscripts. Now the crisscross means that you take the number, whatever the number is, and you crisscross. Okay, now potassium doesn't really have a number, right? Because it's kind of like a 1. So notice how I just flipped the numbers. Now anytime you have a 1 as a subscript, you do not write it. So the final answer would be K3N, potassium nitride, K3N. You can go through this the long way like we just did the last couple of slides and prove it to yourself why we need 3 potassiums to balance nitrogen's charge. What I would like for you to do is go ahead and pause this recording, and I would love for you to go through 2, 3, and 4. Welcome back. Number 2 we see is hydrogen. Welcome back. Number 2 we see is hydrogen. Hydrogen has a +1 charge. Oxygen. Oxygen has a 2- charge. And now we're going to crisscross and reduce. So we're going to have hydrogen with some subscript, oxygen with a subscript. We're going to take only the number and we're going to crisscross just the number as a subscript. So that's 2. Hydrogen, the number is basically a 1, so we're going to write 1. And again, when you have a 1, you do not have to write it. And in fact, you should not. Therefore, when hydrogen and oxygen form a bond, look at that, H2O. I bet you didn't know that. Magnesium and sulfur. Magnesium on our common charges periodic table says Mg2+. Sulfur is S2-. We're going to do our crisscross and reduce. I'm going to write my elements a little bit closer together because it's going to be a compound. I'm just going to save a little bit of space in between to write a subscript. I crisscross the charge. Whatever sulfur's superscript is, that number becomes the subscript here. Okay, I'm going to circle just the number. So just the number comes over. So crisscross, I get 2. Mg2S2. Your subscripts, remember, lowest whole number ratio. 2 to 2 is the same thing as 1 to 1. Therefore, I can reduce it. Okay, 2 to 2 can be reduced to 1 to 1. And remember, we don't write the ones. So this is the formula, magnesium sulfide. Okay, number 4. And you may not even need to use the crisscross method on this problem. You may already see 2 plus, 2 minus. It only takes one of each. But if we were to follow the crisscross method, you do 2, 2, and once again, 2 to 2 ratio, you can reduce, and yes, you must reduce strontium selenide. Here is a quick comprehension check. Please pause this recording and be able to explain why you chose the answer that you chose, or how did you get the answer that you got. Welcome back. Number 1, what is the common charge of the magnesium ion? Well, when we look up on our lovely periodic table that has the common charges in this lesson, we see that magnesium's in group 2, therefore it's going to form a 2+ charge. What is the formula that results when chlorine bonds with barium? Now we have to look on the periodic table, the common charge periodic table, and see which ion each one forms. Barium has a 2+ charge. Each chlorine will only accept 1 electron. Therefore, if barium is getting rid of 2 electrons, I need 2 chlorines to accept. So a 2+, 2- definitely equals 0. Therefore, I need 1 barium and I need 2 chlorides. Barium chloride. Number 3, identify 3 atoms that would lose 2 electrons to empty its valence energy level. Now this is bringing back your knowledge of valence electrons. Which column on the periodic table is going to tell us 2 electrons? Let's go back to our valence electron periodic table. So it says to identify 3 atoms that would lose 2 electrons to empty its valence energy level. Now sticking with the same elements that we've been working with so far this lesson, which column has 2 electrons in its valence shell? If you said group number 2 over here, you are correct. On the left side of the periodic table, you will see group 2 has 2 valence electrons. All of these elements will lose 2 electrons to empty its shell. So you could pick any 3 of these elements as your answer. I'm just going to put these 3. Number 4, what subscripts are needed to complete the formula unit? So we have to figure out what is the formula. Aluminum on the periodic table is in group 3. It forms a 3+ charge. Nitrogen is in group 5. Therefore it has 5 valence electrons. It's going to form a -3 charge. Now we can do crisscross and reduce if you like. So we're going to crisscross. We're going to crisscross Al3 and 3, which is going to equal Aln, no subscripts. Therefore, I would just write Aln. There are no subscripts. If you had a multiple choice question like this, that's the one that you would select, Aln. There are no subscripts. Number 5, which of the following forms a cation? Okay, let's find them all on the periodic table. Bromine is in group 7 and it forms a -1 charge, so that's not the answer. Lithium is on the left side of the periodic table. It forms a positive charge. That could be it, because remember, a cation, cat is positive. Positive. Nitrogen is on the right side of the periodic table. It forms a 3- charge. Therefore, that's not it either. But the correct answer is lithium. Number 6, which of the following is a possible formula unit? I see 3 formulas, so what we have to do is look at each one and make sure that it is correct. A has potassium and nitrogen. So if we do potassium, which has a plus charge, nitrogen, which has a 3 minus charge. So if we crisscross and reduce, we see the 3 comes down here. Potassium has a +1, so that doesn't really do anything. So my formula should be K3N. A is wrong. That is not a possible formula unit. That would not form. Part B, I3N. A lot of students look at this and they say I3N. Okay, well, iodine has a negative charge. Nitrogen forms a 3 minus charge. So if I crisscross and reduce, I3N does form. However, be careful. I and N, no bond, because they're both negative. Therefore, B cannot form a bond. So if we asked you why I3N would not form a bond, it is because they both form a negative charge, and an ionic bond is always a positive ion bonded to a negative ion. Part C. Well, by process of elimination, we know part C has to be the correct answer, but let's prove it. Magnesium's in group 2, forms a 2+ charge. Oxygen is in group 6, forms a 2- charge. So we need one of each element in order to have a neutral charge. +2 - 2 equals 0. Therefore, my correct answer is 0. And that is it for 305. Please make sure that you have mastered these concepts, as 308 will be impossible if you have not. And you need 305 and 308 in order to do all of Module 4. So please set yourself up for success. Join our live help if you need additional help. Ask your teacher, use all the extra resources, and definitely make sure that you are taking notes. Very few people in the world can stare at a computer screen, listen, and learn. You have to write it down. You have to practice it. Thank you so much. Have a great day.